Okay, in this chapter, I'm going to briefly introduce how we can implement sleep for the running description. Well, as I said before, running, there are many, histories about describing running mechanics of the center of mass using the spring. Like compared to the walking, it has a single and double support. Running has a single stance phase and aerial phase. Okay, and then when it reaches to a certain point, then there's a stance phase started again. So if we assume that there are predefined stance configurations with the leg length and the touchdown angle alpha, the ground context starts at y is at a certain position, predefined the touchdown leg configuration, and then it stays on the ground until the stance leg has been totally straightened up. So when the leg length reaches to its natural length L0, then the area phase starts. So it's a simple ballistic falling. That's what we have learned in the very basic physics courses in the high school or the middle school. So your equations of motion for the running using the slim model is the single support phase, and instead of double, it's aerial phase. Aerial phase equations of motions are pretty simple. Only gravity applies. It's a point mass. Again, so for the slim model for the running, you don't model the swing leg. Okay, the stance leg only, and you just assume that swing leg at a certain point having this configuration becoming a new stance leg. And you integrating single support phase until the leg has been straightened up, like L equals to L naught, and you switch to the area phase until the predefined touchdown configuration is satisfied. And then you just keep repeating 2 and 3 back and forth until you find repeated solution, repeated running cycle, repeated gait cycle, the fixed point. And then once you find the fixed point, check the stability. That's pretty similar steps what we have been worked on in the sleep for the walking. Okay, with that, we sort of wrap up the chapter 2.3 as the sleep model, describing the running and walking, the overview of the sleep model and its equations of motion and numerical simulation, and its application to describe or understand human data for the walking and running. Again, that's chapter 2. I should emphasize again that even though either the pendulum model, the spring model could well describe the key characteristics of the walking, that's pretty concept model, pretty like a simple concept model, because real humans, motions are generated very, very complicated, physiological sensory integration and feedback from the muscles. But the benefit for understanding locomotion using the dynamics are, it's a pretty simple model. Using the simple dynamics model, you can understand the force and motion relationship, the key relationship more easily, right? That's the beauty for using simple model approaches. So again, we used the simple inverted pendulum and the spring model to describe the locomotion, and that's the simple example, very simple example for the dynamics analysis. And there are many variety of more complicated, more realistic model exist. And I hope could be a really good introductory session for you who are interested in understanding dynamics of locomotion. So for our next chapter and chapter 3, I'm going to briefly introduce what really applies, what kind of controls are involved for the human motion, mostly about the muscle activation and sensory feedback. Thank you for listening. And finally, I listed up some selected suggested readings that I referred when I made this chapter. Thank you again.